For millions of years, they were the undisputed masters of this planet. Dinosaurs, in their breathtaking variety and colossal scale, roamed every continent, their reign seemingly eternal. Yet around 66 million years ago, this vibrant dynasty vanished from the face of the Earth, leaving behind a profound and enduring mystery. What colossal forces, what catastrophic events could possibly lead to the demise of such dominant creatures? This question has captivated human curiosity for generations, a puzzle etched into the very fabric of our planet's history. The story of their disappearance is not just one of destruction, but also one of incredible scientific detective work. Through meticulous examination of geological records, fossilized remains, and the sophisticated analysis of ancient chemistries, we have begun to piece together the dramatic final act of the dinosaurs. It's a narrative of cosmic collisions and terrestrial turmoil, a sequence of events so profound they reshape the course of life on Earth. Scientists, using ever-advancing technologies and analytical techniques, have now uncovered compelling evidence pointing to the primary architects of this mass extinction event. Join us as we delve into the heart of this ancient cataclysm. We will explore the leading theories, backed by a wealth of scientific data, to understand how these magnificent creatures met their end. This is not merely a tale of what was lost, but a testament to the dynamic and sometimes violent nature of our planet and the remarkable resilience of life itself. We shall journey back in time to witness the forces that brought about the end of an era and paved the way for the world we know today. Our investigation begins with an event of almost unimaginable violence, a cataclysm delivered from the depths of space. Approximately 66 million years ago, an asteroid, estimated to be some 10 kilometers in diameter, hurtled through the cosmos on a collision course with Earth. Its destination, the shallow seas of what is now the Yucatan Peninsula in Mexico. The impact, known as the Chicxulub event, was a moment that irrevocably altered the destiny of life on our planet. The sheer scale of this cosmic visitor is difficult to comprehend. A mountain-sized rock, traveling at speeds many times faster than a rifle bullet. The energy unleashed upon impact was staggering, equivalent to billions of atomic bombs detonating simultaneously. The immediate effect was a colossal explosion, vaporizing the asteroid itself and vast quantities of the Earth's crust. This sent a searing shockwave and a plume of superheated debris, rock and dust high into the atmosphere, and even beyond. Gigantic tsunamis, hundreds of meters high, raced across the oceans, devastating coastal regions thousands of kilometers away. The sky itself would have appeared to ignite as ejected material rained back down, heating the atmosphere to oven-like temperatures and triggering widespread global firestorms. These infernos would have consumed vast swathes of vegetation, a critical foundation of the Cretaceous food web. But the devastation did not end there. The immense cloud of dust and soot, a mixture of pulverized rock and smoke from global fires, was so thick that it shrouded the planet in darkness. This impact winter would have persisted for months, perhaps even years, drastically blocking sunlight from reaching the Earth's surface. Photosynthesis, the very process that sustains plant life, would have ground to a halt on a global scale. With plants dying, the herbivorous dinosaurs from the mighty Triceratops to the vast herds of hadrosaurs faced starvation. Their decline, in turn, meant a critical shortage of food for carnivorous giants like Tyrannosaurus rex. The intricate food chains, built up over millions of years of evolution, began to unravel with terrifying speed. This single, devastating blow from space initiated a cascade of environmental catastrophes, pushing ecosystems worldwide to the brink of total collapse, marking the primary and most immediate cause of the dinosaurs' demise. While the Chicxulub impact delivered a swift and brutal shock to the global ecosystem, another colossal geological force was already at play, contributing to the environmental stress that life on Earth was experiencing. In what is now India, a vast volcanic province known as the Deccan Traps was undergoing a period of truly monumental eruptive activity. These were not your typical conical volcanoes. Instead, they were fissure eruptions, where lava poured out from immense cracks in the Earth's crust, flooding hundreds of thousands of square kilometers with molten rock, layer upon layer. This immense volcanic outpouring, one of the largest volcanic features on Earth, had begun before the asteroid impact and continued for a considerable time afterwards. The sheer volume of lava released is almost beyond imagining, in places forming basalt layers several kilometers thick. But it wasn't just the lava that posed a threat. These eruptions also spewed vast quantities of gases into the atmosphere, sulfur dioxide, carbon dioxide, and chlorine amongst them. These gases had profound and far-reaching consequences for the global climate system, acting as a slower but incredibly potent agent of change. The release of enormous amounts of sulfur dioxide would have led to the formation of sulfate aerosols in the stratosphere. These tiny particles are highly effective at reflecting sunlight back into space, which could have induced periods of global cooling, further stressing ecosystems already reeling from other changes. Conversely, the massive injection of carbon dioxide, a potent greenhouse gas, over extended periods would have contributed to long-term warming trends, disrupting established climate patterns and habitats to which the dinosaurs and other contemporary life forms had adapted over millennia. Furthermore, the volcanic gases, particularly sulfur and chlorine compounds, would have reacted with atmospheric water vapor to produce acid rain. This corrosive precipitation would have fallen across the globe, damaging vegetation on land, and crucially, altering the chemistry of the oceans. Acidification of the surface waters would have severely impacted marine organisms, particularly those with calcium carbonate shells, such as plankton, which form the base of the marine food web. Thus, the Deccan Traps represented a persistent, planet-altering assault on the Earth's biosphere. A slow burn compared to the asteroid's flash, but devastating nonetheless. It becomes increasingly clear, as we examine the evidence, that the end of the Cretaceous period was not brought about by a single isolated disaster, but rather by a devastating confluence of catastrophic events. The Chicxulub asteroid impact and the prolonged massive eruptions of the Deccan Traps, though different in their nature and timescale, appear to have acted in a grim synergy. The Earth's systems were assailed from both without and within, creating a perfect storm of environmental pressures that proved too much for many species, including the non-avian dinosaurs, to withstand. Imagine the scenario: a world already stressed by the climatic shifts induced by the Deccan Traps outgassing, perhaps experiencing fluctuating temperatures, acid rain, and poisoned seas, is then struck by the cataclysmic asteroid. The impact's immediate effects, the firestorms, tsunamis, and the prolonged darkness of the impact winter, would have been an acute shock, an almost instantaneous push towards collapse. Ecosystems that were already weakened and less resilient due to the ongoing volcanic activity would have been far more susceptible to this sudden, brutal blow from space. There is also compelling geological evidence suggesting that major changes in sea levels were occurring around this time. Regressions or falls in sea level would have exposed vast areas of continental shelf, drastically altering coastal habitats and potentially impacting marine biodiversity even before the asteroid struck. These sea level fluctuations could have been driven by tectonic activity or changes in global ice volume, adding yet another layer of environmental instability to an already volatile world. Climate too was likely in a state of flux, not just from volcanism, but potentially from complex feedback loops within the Earth's systems. Therefore, the mass extinction event at the Cretaceous-Paleogene boundary was likely a complex, multi-causal crisis. The asteroid impact provided the immediate, devastating trigger, pushing already stressed ecosystems over the precipice. The Deccan Traps volcanism acted as a long-term press, weakening the biosphere and contributing to a hostile global environment. Combined with other potential factors like sea level and climate changes, these forces created conditions that were simply unsurvivable for the dinosaurs and a vast array of other species, fundamentally resetting the evolutionary trajectory of life on Earth. In the wake of such monumental devastation, it might seem as though life itself was on the brink of utter annihilation. Indeed, an estimated 75% of all species on Earth vanished. Yet, amidst the ruins of the Cretaceous world, survivors endured. Perhaps most remarkably, some dinosaurs did survive. Not the colossal land dwellers, but their feathered descendants, the birds. These agile, adaptable creatures, many capable of flight and exploiting diverse food sources, navigated the cataclysm and carried the dinosaurian lineage into the modern world. Alongside the nascent birds, other, often smaller creatures found refuge and opportunity. Tiny mammals, hitherto living in the shadows of the great reptiles, emerged from their burrows into a world emptied of its giant competitors. Reptiles such as crocodiles, turtles, and lizards, along with amphibians like frogs and salamanders, also weathered the storm, their resilience tested but not broken. In the oceans, while many magnificent marine reptiles and countless smaller organisms perished, some fish, sharks, and invertebrates managed to persist, laying the groundwork for future marine ecosystems. The story of the dinosaurs' extinction is a stark reminder of the Earth's immense power and the sometimes fragile nature of existence. Yet, it is also a profound testament to the tenacity of life. From the ashes of a fallen world, new forms emerged, new evolutionary pathways opened, and the intricate tapestry of life began to reweave itself. The planet healed, adapted, and life, in its incredible diversity, continued its unending journey, forever shaped by the day the giants fell, yet always striving, always evolving, towards the next chapter. But imagine for a moment the sheer destruction unleashed as the asteroid struck, an explosion so immense it reshaped the world in an instant.